When you're working with addition and subtraction, you're probably going to find it useful to draw some counter diagrams like you used in the place value activity from last week. You're going to be asked to write two-digit numbers in your base using only the digits that you're allowed. So remember, in base 2, I only have zeros and 1. So I'm going to create two-digit numbers, and I'm going to do 1, 0, and I'm going to add to that 1, 1. In order to make this make sense, I'm also going to do a visual representation with counters. So I'm going to make another chart. The only difference here is that I've chosen to label the names of the positions at the top. I'm going to take my base 2 number, and again, when you start filling the positions, you fill from the right. So the 0 is in the 1's place, and the 1 is in the 2's place. But I think you're going to find it more helpful to have less numbers flying around and more pictures to focus on. So rather than putting the digits, instead I'm going to put the number of counters in that spot. Remember, in our activity, you had a box for tens and a box for ones, and you put different pennies in different boxes. So for instance, if you had 2 counters here and 1 counter here, this would be the number 21, 2 tens and 1 1. We're going to do the same thing here. My rightmost position says I have no ones, so no counters go in this box. But I do have 1, 2, so I put in a counter. Now the number 1 1, I have 1 counter in the 1's position, 1 counter in the 2's position. And in order to perform addition, remember, is the operation of totaling things up. So I'm going to just combine the items in the ones column and the items in the 2 columns in a new chart. Now I'm ready to go back from counters to digits. All right, 1 counter, that's the digit 1. 2 counters, you're used to that being the digit 2. But remember, in our system, there is no digit 2. So what do? What we do is the idea of regrouping. Remember how, when we were working in the base 10 system, I circled any groups of 10 and moved that counter into the next column. I'm going to do the same thing in base 2, but instead of circling a group of 10, I'm looking to circle a group of 2. Every group of 2 now can be represented as a single counter in the next column. Why? Well, keep in mind, each of these counters is in the 2 column. So this counter is worth 2, this counter is worth 2, 2 plus 2 is 4, and significantly, it is 1, 4. And once I do that regrouping and move it to the next column, there's no more counters here. Now I can go back to writing my digits. There's no digits in the 2's column, and I have 1 digit in the 4's column. So the answer to this math problem looks like this. So 1 0 plus 1 1 is 1 0 1. And if you were working through the algorithm, you would do 0 plus 1 is 1, and 1 is a digit in this system, so that's fine. When you got to 1 plus 1, 2 is not a digit in this system. So I can't put the number 2 here. I'm really trying to say I have 2 2's, which is the same as 1 4. So I would carry that 1 over into the next place, giving me a number in the 4's place. The next problem asked me to write 1 2-digit and 1 3-digit number. And to do one that's complicated and has lots of regrouping, I'm going to choose lots of ones. So 1 1 will be my 2-digit number, and 1 1 1 will be my 3-digit number. These are base 2 numbers. As before, I'm going to go ahead and put counters that represent each position. Now I try to total my counters. So I have 2 counters in the 1's column, 2 counters in the 2's column, and one counter in the fours column. But when I start to write the digits of my answer, I want to put a 2 here. There are 2 counters. 2 is not a digit in my system, so I'm going to need to regroup. And when I'm grouping, I am looking for groups of 2, not 10, because this is base 2. For every group of 2, I'm able to move and put a counter next door. Why? Because this counter is 1, 1 plus another 1 would equal 2. And that is a single 2. Once I move that group over, they're gone. And my digit that I would put in the ones place should be 0. Okay, now I count my counters in the twos position. I have 3 of them. Is 3 a digit in my number system? Gosh darn it, no. So I look to group, instead of grouping into tens, I'm looking for groups of 2. I can take 2 counters, and remember, if each one is a 2, I have 1 2 plus another 2 makes a 4. So I can put 1 counter in the 4 column, and then I can get rid of these 2. Now notice that did leave a counter behind. So when I'm recording the digit, I now record a 1. I count the counters in my 4 spot. There's 2. Can't use a digit of 2. So regroup. Find a group of 2. This represents 2 4s. And 4 plus 4 is the next spot I don't even have prepared, which is going to be the 8s. So I'm going to create a spot to record my 8s. I'm going to put 1 counter for every group of 2. These disappear, and so my digit, so the digit in this place will be 0. And lastly, there is 1 counter in the 8th spot, and the digit 1 is allowed in my system, so therefore I put a 1. So the answer to the sum of what is 1 1 plus 1 1 1, surprisingly, is 1 0 1 0. And notice I did not line up my digits simply because I would have had to write on top of my 8s position. The next part asks you to perform subtraction. When you're combining two numbers together with addition, you just total them. When you're subtracting, you take whatever's in the first position and you take away however many you're looking to subtract. I've written two-digit numbers, the number 10 and the number 01. It's not customary to put a leading 0 in a number, but in order to do some regrouping, I want to make sure that I have a 1 in this position. And I can't put a 1 in this position because then this number is bigger than this number. We get into negatives, and I just don't want to go there. So just allow me to use this number as my second two-digit number. I begin by representing these in terms of counters. Now, if you ask any elementary school child, if you have 0 and someone wants to take away 1, they can't. 0 is smaller than 1. So what am I going to do? Well, the good news is you can borrow. This counter in the twos position, remember, originally came from combining a group of 2 1s. This 1 counter represents a value of 2. I can take those 2 and go back to the ones place. So I'm doing the opposite of the process we did with addition. Once I put those 2 dots in this position, I can erase the counter from the twos position. Now, am I able to take away 1 counter from 2? Get rid of this one with this one, leaving 1 counter behind. And then my math is done because everything else is empty. And am I able to write 1 counter as a digit? Yes, 1 is allowed. So when I do 1 0, take away 0 1, I'm left with just the number 1. which incidentally, if you're wondering, yes, could be the same as writing the number 01. And if you think about it, here's why. This is the number 10. The 1 is in the twos place. So this is the number 2 in base 10. We have a 1 in the ones place. So this is the number 1 in base 10. And when you do 2 take away 1, you get, we have a 1 in the ones place. You get 1 in base 10. Take the little tens off, and that should look very familiar. In terms of the algorithm, I see that I need to do 0 take away 1, and so I need to go to the next column and borrow. And this is that algorithm that most kids are taught, and they're really just taught these rules instead of the visual of the counters and why I'm going to the next column and bringing it back. So unfortunately, there are students who just learn, okay, lower this number by 1 and then bring it over here. And keep in mind, I'm not bringing over a 10, I'm bringing over a 2. 2 take away 1 is 1. So I think it's helpful for students to not just have a teacher explain, oh, you got to go to the next one and you got to borrow and you got to bring it back. With the counters, they can actually move those numbers around and have some understanding of what it is that they're doing. We're going to do one more of these subtractions. In this example, we're supposed to write a 2-digit and a 3-digit number in your base. Now, because we're going to do subtraction, you're going to want your 3-digit number on top. This time I'm going to go with the number 101. And below it, I will put the 2-digit number 1 1 in base 2. Subtract. First, represent with counters. I have 1 1, no 2s, and 1 4. In my second number, I have 1 1 and 1 2. Now, the beginning of this subtraction is easy. If I have one counter and I take away one counter, well, I'm left with 0 counters. And so my first digit of my answer is 0. In the twos column, I have no 2s and I'm supposed to take something away. Uh-oh, I need to borrow some 2s from somebody. How do I do that? Well, again, I look in the next column over and I can see, oh, hey, there's a 4 sitting here. 4 is how many 2s? It's 2 of them. So once I perform that borrowing, I no longer have a 4 counter because I have 2 2s. If I have 2 2s, I'm a ballerina. Ha, get it? If I have 2 2s, take away 1 2. How many 2s am I left with? A single counter. That can be represented by the digit 1. And all of a sudden, my 4s are all used up. And so this is the end of my number. In other words, here's my subtraction problem. Now remember, you could do this as an algorithm this way. 1 take away 1 is 0 in any base. That's pretty simple. But when I go to the next column, I have no 2s and I'm trying to take away 1. Where could I get some 2s? I can cash out this number here in the 4s position. That 4 is the same as 2 in the 2s place. So now I have 2, take away 1, which is 1. Again, same kind of process we use in base 10, but we're thinking in terms of 2s. And to end on kind of a fun, creative note, I'm asking you to stretch your brain a little bit here at the end. So our base 10 number system is literally based on the fact that we have 10 fingers. So if we're counting, kids naturally just count on their fingers. Well, so did people many centuries upon centuries ago. What I'd like you to do is invent a kind of alien that uses your number system. Give the alien group a name, draw a picture of a typical alien, and write up a reasonable explanation for why, based on their appearance or something in their environment, this group would use the base of your number system instead of base 10. I've been using the example of base 2. So I'm going to draw an alien who would have a reason to be using 2 as their basis for counting. We're going to draw a bit of a blobby dude. And Mr. Blobby Dude has some friendly little eyes there. Doesn't have a nose. Has some giant teeth-like things going on here. And notably, Mr. Blobby Guy doesn't have hands, but he does have cute little fuzzy antenna coming out the top. And yeah, he doesn't have feet. Okay, so I've invented an alien. I am going to call this group of aliens the blobbies. And the blobbies have 2 antennae in particular. I'm not going to take the time to write up a sentence right now, but when I ask for that reasonable explanation, I would say, well, the blobbies don't have hands, but they do have 2 antennae that they can move. They only have 2 things to count on, so they use base 2. Come up with something creative and cute. Don't take more than like 5 minutes. You don't have to be super artistic here, but that's the idea.